For 7.2, we're going to estimate the population mean when we don't know what our population standard deviation is. So we don't know what our sigma is. Now with this, we have to use a new table. So in your table packets, it's not the Z table anymore, it's going to be the T table. So if you don't know the population standard deviation, we have to use this T table. That's our student's T distribution. We use that when the sample standard deviation, S, is known as an approximation for our sigma, the population standard deviation. Again, you have to use this table if you don't know sigma. So if you're not sure what sigma is, if they don't tell you in the problem, you have to use the student's T distribution, so the T table. Now, they give you a formula to find what T is equal to, but we can go through and do everything on our table and things with our calculators. So you will not have to physically figure out what that T value is. So for a T distribution, the distribution is symmetric about the mean, 0. Distribution depends on the degrees of freedom, your DF, and that's going to be n minus 1. So if you're trying to figure out what your DF is, you have to have n minus 1. So your number in your sample minus 1. Because you'll see in the chart, they're going to ask about degrees of freedom. They're not going to ask for your n. So it's always n minus 1. The distribution is your bell shape. Degrees of freedom increases, the T distribution approaches the standard normal distribution, and the area under the curve is 1. So it's a lot of the same type of curve that we have for the Z table, but again, now we have our T table. Now going through this, we're still going to do the exact same thing for our interval when we want to find our confidence interval. However, to figure out your critical value now, you have to go through the T table. There's not a nice little chart that we have like we did in the Z table. Now you actually have to go to the T table and you're going to figure out what that TC, or critical value, is. So when you are going through and using your T table, if the degrees of freedom you need are not in the table, use the closest degrees of freedom in the table that is smaller. So let's say you need like 53 and it's not on the table. You have to go to 50 if that's on the table. So you have to always go down on your table. Don't go up to figure out what your degrees of freedom is going to be to match up to find your confidence value, your critical value. Okay, so looking at example 4, it says find the critical value for 0.99 when we have a sample size of 5. So my degrees of freedom then is going to be 5 minus 1, which is 4. So we're going to go to our table and we want to figure out for the 0.99, not 0.999, but 0.99, and we want a degrees of freedom of 4. So here's our table here. Your degrees of freedom is that first column. So we're going to go 4 because that stretches out over here on this row then. And you want 0.99. Like I said, not 0.999. You want 0.990. So I match up 4 with 0.990. So that means the TC would be 4.604. This is the same thing as our ZC when we went through it in 7.1. So you are going to need to know that TC in order to be able to find your estimation, your E values there. Okay, I want you to do the same thing. You're looking at 0.900, and you have a sample size of n equals 9. So go through what we just did, pause the video, see if you can find it, and then come back to me. Okay, so if my n is 9, my degrees of freedom is going to be 9 minus 1, so 8. So we have to figure out then in our table when we're on 8 and we have a column of 0.900, we got to find the number. So I have 8 here and we want 0.900, so it looks like it's 1.860. So again, we should have then 1.860. So you need to use that table to figure out what your TC value is so you can find that E, that margin of error. So it's the same type of equation as 7.1, but now it's a T instead of a Z, and it's an S instead of our sigma, because it's still standard deviation on top, square root of n on the bottom. Going through your confidence interval, it's the exact same stuff. You must have 30 or bigger for your n for that to be that normal distribution if it's not stated. But if it is stated, then it doesn't matter what your size for your n is. We're going to find our confidence interval doing the same thing. X bar minus E, X bar plus E. And we're going to write our sentence just like before. So really a lot of this is the same. However, going through it, we have to make sure we're using the T-table. We can't just use our nice little Z chart that we had. Okay, so for example 5, suppose an archaeologist discovers 7 fossil skeletons from a previously unknown species of miniature horse. Reconstructions of the skeletons of these 7 miniature horses show the shoulder heights to be, we have our list. For these sample data, the mean X bar is 46.14, and the sample standard deviation is S equals 1.19. Let mu be the mean shoulder height for this entire species of miniature horse, and assume that the population of shoulder heights is approximately normal. Find a 99% confidence interval for mu, the mean shoulder height of the entire population of such horses. So going through this, we need to know a couple things. So in order to find our E, we have to know what our N is. They're telling us there are 7 horses. We have to know our degrees of freedom, and that has to be 6 because it's 1 less than that 7. So you need to go to your table then. We want 99%. So you're trying to find in the row that has a 6 for degrees of freedom, you want 0.990 for your column to match it up. So look in your table right now for your T value that matches up with a degrees of freedom of 6 and a 0.990 then for your confidence level. So going through that, you should see you have a 3.707. Now, if we want to figure out what our E is, there's one more thing we need, and that's our S. They tell us 1.19. So I have E is TC S over square root of N. So again, all we have to do is plug all that information in, just like we did in 7.1. Make sure you do square root of n, not square root of df. And going through this then, when I plug everything in, we should have for our E 1.67. So we have to take x bar minus it and x bar plus it. Now they told us in the problem here that our x bar is 46.14. So minus that 1.67. So that means my interval should be between about 44.5 and 47.8. So just like 7.1, we're going to write our sentence. So we are 99% confident that the interval from 44.5 centimeters to 47.8 centimeters. Contains the population mean for shoulder height of this species of miniature horse. Again, it's pretty much the exact same sentence that we had before. So really there's nothing different except now you have to use the T table and you have an S. Everything else is the same except of those two parts. So it's exactly like 7.1. So if we can do 7.1, we can do 7.2. So I'm going to have you do one on your own then. We're going to read this over together. A company has a new process for manufacturing large artificial sapphires. In a trial run, 37 sapphires are produced. The distribution of weights is mound shape and symmetric. The mean weight for these 37 gems is X bar equals 6.75 carats, and the sample standard deviation is S equals 0.33 carat. Let mu be the mean weight for the distributions of all sapphires produced by the new process. Find a 95% confident interval for mu. What does the confidence interval tell us in the context of the problem? So we're doing the exact same thing we just did in the last problem. So I want you to pause the video, go through these, and look at the last problem to see how to set it up and see what you can do on your own. Okay, so you should have something written down for this. You know your N is going to be 37 because there's 37 gems, which means your degrees of freedom has to be 36. Then going through this, we have a confidence interval of 95%. So if I want to find my TC, we need to look for a 0.950, and I want degrees of freedom of 36. So if I go to my table here, 36 is not listed. Remember, you have to go lower, not higher, but lower. So you want 35. So we have to look at 35, and we're looking at that 95%. So if I'm 35 and 95%, it looks like we are 2.030. We also need to know what our S is. They say 0.33. So E is equal to TC S over square root of N. So we've got 2.030. My S was 0.33 over square root of 37. So when I type that in, it looks like we should have about 0.11. So we have to do X bar minus and X bar plus. So I have 6.75 minus 0.11, 6.75 plus 0.11. So we have about 6.64 to about 6.86. So we are 95% confident that the interval from 6.64 carat to 6.86 carats contains the population mean weight of sapphires produced by the new process. So again, going through this, it's the exact same thing that you've been doing. You should know how to go through and be able to find your confidence interval. Now again, you're going back and forth thinking, how do I know which one to use? When you know sigma, that's when you use your z-table. So if you know sigma, it's the z-table. If you know s, it's the t-table. So sigma goes with z, s goes with t. Now you can also do this on your calculator, but again, it's not going to give you what your e value is. And I don't really use this much because I would much rather just type it into my calculator and see it by hand. So going through it, we're going to hit the stat button. We're going to go over to tests. Now you want t interval. Again, leave it on stats there. Now, going back up to our last problem here. Our x bar was 6.75. Our s, that's your standard deviation, 0.33. Your n here was 37, and our confidence interval was 0.95. So it should have between about 6.64, 6.86, which is what we have in our interval. So again, if you want to check yourself, this would be a great way to check yourself. But you still have to know how to find your E, because you will have to find your E on your test too without being able to type things into your calculator, because the calculator does not give you what E is. Now in WebAssign, watch and see how they want you to round, so make sure you're rounding correctly as you go through it. Some of the problems, they're going to require you to find your X bar and your S. You should know how to do that. That's when you plug everything into your L1 and do your 1 var stats. So you're going to have to find X bar and S sometimes too as you go through these. And look at my WebAssign help. It will help you go through some of those harder problems on how to set things up. Again, if you have questions, send me questions and we can go over any problems that you want to do together.